Welcome to this video on Structural Analysis 2, where we will be focusing on the study of fixed arches. In this lecture on structural analysis, we will analyze a parabolic arch fixed at both ends. The arch features a total span of 42 meters and a central rise of 8.5 meters. It carries two concentrated point loads, 75 kilonewtons at 8 meters from the left support and 100 kilonewtons at 16 meters from the left support. The second moment of area varies as the secant of the inclination angle. Our goal is to complete the full structural analysis and find the bending moments at the supports and at the crown. Let's examine the mathematical setup.
To analyze any point along the arch axis, we first derive the parabolic elevation equation for central rise, y. The general parabolic relation is y equals 4yc over L squared times x times open parenthesis L minus x, close parenthesis. Substituting our central rise yc of 8.5 meters and total span L of 42 meters into the equation gives 4 times 8.5 divided by 42 squared multiplied by x times open parenthesis 42 minus x, close parenthesis. This simplifies directly to y equals 0.0193x times open parenthesis 42 minus x, close parenthesis. We will use this spatial elevation profile in our strain energy integrals.
Next, we establish bending moment expressions mx taking origin at right support B. Measuring from B, the 100 kilonewton load acts at 26 meters and the 75 kilonewton load acts at 34 meters. For portion BE, from 0 to 26 meters, mx equals vb times x minus hb times y minus mb. For portion ED, from 26 to 34 meters, mx equals vb times x minus hb times y minus mb minus 100 times open parentheses x minus 26 close parentheses. For portion DA, from 34 to 42 meters, we subtract 75 times open parentheses x minus 34 close parentheses. Taking partial derivatives of mx with respect to vb, hb, and mb yields x minus y and minus 1, respectively. Because both ends are rigidly fixed, there is zero displacement or rotation at support B. Applying Castigliano's theorem, the partial derivative of total strain energy U with respect to vb, hb, and mb equals 0. Applying Castigliano's theorem, the partial derivative of total strain energy U with respect to Vb equals 0. This expands into 1 over EI0 times the integral from 0 to 42 of mx times x dx, which equals 0. We integrate mx times x across all three segment limits, 0 to 26, 26 to 34, and 34 to 42 meters. Evaluating these definite integrals leads to our first governing equation, 2.47 times 10 to the power of 4 VB, minus 5 times 10 cubed HB, minus 882 MB, minus 5.637 times 10 to the 5th equals 0. Next, setting the partial derivative of total strain energy, U, with respect to horizontal thrust HB equal to 0, gives 1 over EI0 times the integral from 0 to 42 of mx times minus y dx equal to 0. Substituting our elevation equation for y and integrating mx times minus y across all three segments from 0 to 26, 26 to 34, and 34 to 42 meters, we arrive at our second governing equation. Minus 5 times 10 cubed vb plus 1.81 times 10 cubed hb plus 2.38 times 10 squared mb plus 4.98 times 10 to the 4th equals 0. Finally, setting the partial derivative of total strain energy U with respect to support moment mb equal to 0 gives 1 over EI0 times the integral from 0 to 42 of mx times minus 1 dx equal to 0. Integrating mx times minus 1 across all three segments leads to our third governing simultaneous equation, minus 882 VB plus 2.38 times 10 squared HB plus 42 MB plus 1.51 times 10 to the 4th equals 0. We now solve equations 1, 2, and 3 simultaneously to determine the unknown support reactions at B. Solving these three simultaneous equations yields vertical reaction VB equal to 39.6 kilonewtons, horizontal thrust HB equal to 78.47 kilonewtons, and support moment MB equal to 25 kilonewton meters. To find vertical reaction VA at the left support, we apply global vertical equilibrium. VA plus VB equals total vertical load of 175 kilonewtons. Therefore, VA equals 175 minus 39.6, giving 135.4 kilonewtons. To find support moment MA at left support A, we take moments about A and equate to 0. MA equals minus 42 VB plus MB plus 100 times 16 plus 75 times 8, which yields MA equal to 561.8 kilonewton meters. Next, to calculate moment MC at crown C located 21 meters from B, MC equals 21 VB minus MB minus HB times 8.5. Substituting our values gives MC equal to 21 times 39.6 minus 25 minus 78.47 times 8.5, resulting in 139.61 kilonewton meters.
Thank you for watching. We have successfully completed the structural analysis of this fixed parabolic arch using Castigliano's theorem, determining all support reactions as well as bending moments at both fixed supports and at the crown. Keep practicing, and I will see you in the next lecture.